For section 331, example 4, we are going to continue with graphing quadratics using the functions and the characteristics that we've already talked about. So in example 4, gives us the quadratic function g of x equals negative x squared plus 8x minus 17. It says to determine the direction in which the function opens, the vertex, the equation of the axis of symmetry, the x-intercept or intercepts, depending on how many we would have, and then, if any, the y-intercept, and use this information to sketch our graph. So the first thing we're going to find or look at is determine the direction of which the function opens. Remember, to determine which direction it opens, we're going to use our a value. So in this particular equation, we have an a value of -1. We have a b value of 8 and a c value of -17. So we are going to be using our a value. If our a value is negative, if our a value is less than 0, our graph is going to open down, which means we would have a maximum up at the top. So when we do find our vertex, we would know that it is a maximum. So we've done our first part. The second piece says to find the vertex. Now remember, our vertex is a two-step process. The first piece is we're going to do -b over 2a. That's going to find the x value, and then we're going to plug that back in. So using what we know, -b over 2a would be -8 over 2 times -1. This simplifies to 4. And now what we do with 4 is we plug it back into the original equation. Everywhere we see a variable, or in this case an x, we're going to replace it with that 4, plug it into a calculator to see what comes out. So if I plug in a 4 for each of these positions, type that in, we get a -1, giving us a vertex at 4, -1. So remember, that's from finding our a value. That is our maximum because our graph is going to open down. The next thing it asks us to find is the equation of the axis of symmetry. Remember that axis of symmetry is the x value of our vertex, and it's the vertical line that splits our graph into two equal pieces. So that's what helps us find our missing coordinates, our missing points, once we go to graph. So we have an axis of symmetry at x equals 4. Next piece, it says to find our x-intercepts. So our x-intercepts, those are what we've been solving for the last few days using the quadratic formula. So we're going to use the quadratic formula again. So in order to find our x-intercepts, we are going to take quadratic formula, -b plus or minus the square root b squared minus 4ac all over 2a. So if we plug in that information, we would have -8 plus or minus the square root of 8 squared minus 4 times -1 times -17 all over 2 times -1. Now remember, when we simplify these, we want to simplify piece by piece. So the first piece we're going to work towards is just simplifying what's underneath the radical. So we leave the -8 plus and minus the square root out in front, leave all that, and we're just typing in what 8 squared minus 4 times -1 times -17 is, and that's going to give us a -4. Now before we go any farther, remember when we talked about the discriminant, that number that is underneath, anytime this number underneath is a negative number, we instantly have no solution. We have no x-intercepts. So a negative number tells us that we have no x-intercepts. So that all that means is we're still going to have a graph. It's just never going to cross the x-axis. So the last piece of information we have to find is going to be our y-intercept. And if you remember, the y-intercept is simply at our 0, c. So our c value in this case would be 0, -17. So we're going to use all these pieces of information, all these coordinates that we found, to put a graph together. So if we start with the pieces we know that we have a vertex at 4, -1. So there's our vertex at 4, -1. Same dot right here, we know that this is our axis of symmetry. So we know that this line at x equals 4 is going to go perfectly through the middle. So whatever we have a dot on the right, the same dot is equal on the left, and vice versa. We also know that we have a y-intercept at 0, -17, just down there on the left. We have no x-intercepts, which makes sense because we know our graph is going to open down from our blue vertex and go through our y-intercept. So we'll zoom in on our graph. This isn't very much information to make our graph from, so that's why we're going to use that axis of symmetry. If we know that we have an y-intercept at 0, -17, this dot is 1, 2, 3, 4 spots away from our axis of symmetry. We can go 4 in the other direction, 1, 2, 3, 4, and know that we also have a dot on that side of the graph. So what this allows us to do is create that symmetrical quadratic parabola going through dots on both sides. So we found all the pieces, put what we knew on the graph. We know we have no x-intercepts, which our yellow graph never touches that x-axis. Opens down, vertex at 4, -1, axis of symmetry at x equals 4, and a y-intercept at 0, -17. In example 5, they're asking us to do the problems that we've been working with backwards. Typically the questions we've been working with is they're giving us a quadratic function and they're asking us to find some characteristics and put it onto a graph. In this particular question, they're giving us some of those characteristics and asking us to make an equation. So if we remember, a quadratic function that we've been working with for months now is ax squared plus bx plus c. They're asking us to take the information that they're going to give us and find out what the a, b, and c value are supposed to be. They tell us that we have a vertex at 2, -4. Remember, 2, -4 is a coordinate. So 2 would be our x coordinate and -4 would be our y coordinate. We also know that when it comes to a vertex, this first value came from the formula -b over 2a. We're going to use that to help us find what our values are supposed to be. They also let us know that we have a y-intercept of 4. Remember, our y-intercept is also our c value. So we have one number found. We know our c value is going to be 4. Now we just have to work to find our a and our b. So the first step we're going to do is use that value of 2 from our vertex and the equation we know to find the vertex and find some values. So if we know -b over 2a is going to give us the value of 2, we're going to use this equation, work our way backwards, and find something to plug in for b. So if I want to get the b value by itself, this right here, the first thing I would do is multiply both sides by 2a, undoing that division. So we would have -b equals 4a. Last step would be to divide both sides by -1, giving us b equals -4a. Now that's not a perfect answer, it's not our final answer, but it does give us something to plug in for b. So if we use our original equation, we're going to plug in for the pieces that we do know, and we're going to solve for the pieces that we don't. So if this is our original equation, we don't know what a is, so we're going to leave a on its own. We know what an x is, so we know our x is a value of 2 that came from our vertex. We know our b is going to be our -4a, again, using the 2 for our x value. We know that our c value is going to be a 4. And then the last piece is we know this is all going to equal -4, because if we were to plug all this into the equation, that value is going to come out for that y value. So now we just have to solve for the last variable we have left, and that's the a. So the first thing we want to do is simplify everything down and start combining like terms. So in this first piece here, we have 2 squared times a. 2 squared is 4, giving us a 4a. In our second piece here, we have negative 4 times 2, giving us a minus 8a. Positive 4 stays the same, and then equal negative 4 stays the same. So using this to combine some like terms, 4a minus 8a gives us a negative 4a plus 4 equals negative 4. If we move the positive 4 by subtracting on both sides, we get negative 4a equals negative 8. Divide both sides by negative 4, we get a equals 2. So originally, we already know our c value. We started that from the beginning. We just plugged in what we knew to solve for a. The only piece we have left is to solve for b. So we're going to take this value for a, plug it into this equation right here to find our missing piece. So if we know that b equals negative 4 times a, we're going to replace that a value with the 2 we just found to find that b equals negative 8. So we have an a value of 2, a b value of negative 8, c value of 4, making our final equation. Remember, we're writing it in the standard form, ax squared plus bx plus c. So we would have 2x squared minus 8x plus 4. Final answer.